And we are continuing on with average rate of change, also known as slope. A linear function is an equation between two variables that gives a straight line when plotted on a graph. And the slope of the line between two distinct points is given by an equation, m, which is what the slope stands for, y2 minus y1 over x2 minus x1. I'm just going to rewrite this y because it got a little bit away from me. So we're going to look at linear functions. So we're going to look at straight lines. We're going to find the slope or the rate of change of those straight lines. And we're going to do that by finding two distinct points on those lines and using this formula to find that slope. So possibilities for the slope of a line, you can have a positive slope. It's when the value of m is bigger than 0. You can have a negative slope when the value of m is less than 0. You could have a 0 slope, so that's a horizontal line. It's when m is equal to 0. Or you can have an undefined slope. That's when the line you're looking at is vertical. M is undefined because when you set up this fraction up here, y2 minus y1 over x2 minus x1, the denominator ends up being 0. We cannot divide by 0. That is undefined, and that's what happens when you have a vertical line. So 4 possibilities for what our slope could look like. So we're going to start with some basic examples, just looking at 2 points, using this formula to find the slope of the line passing through the points. So I'm going to rewrite that slope formula here. So first pair of points, -3, 4, and -4, -2. It really doesn't matter which ones you make your x1, y1, your x2, y2, but they have to be together. So I'm going to make this x1, y1, x2, y2. So the two that are together, that's your x1, y1, and the other two that are together, that's your x2 and your y2. So now using the slope formula, I'm going to take the y2, -2, and I'm going to subtract y1, which is 4, divided by x2, -4, minus x1, -3. -2 minus 4 is -6. -4 minus a -3. So remember, this is the same as addition. So that's -4 plus 3 is -1. -6 divided by -1 is 6. These points, if we were to plot them on a graph and connect them, they would have a positive slope. And that slope would have a slope of 6. So that means that slope of 6 means you go up 6 and over 1. And then you find another nice pretty dot on the graph. And then you go up 6 and over 1, and you have another nice pretty dot on the graph. And you go up 6 and over 1, up 6, over and over and over again. So our next one, again, I'm just going to arbitrarily say x1, y1, x2, y2. Doesn't matter. I could have flip-flopped the 1s and the 2s, but the 1s and the 2s have to stay together. So y2 is 5 minus -2 over -1 minus 4. So this becomes 7 on top, because that becomes addition. -1 minus 4 is 5. You can leave this as a fraction, because this tells me that if I go, that's -5. This tells me that I can go up 7 and down 5 on the graph, and I would find another pretty point that I could plot and then connect the lines, and I would have my beautiful line. Or you can go ahead and you can turn this into a non-fraction number of -1.4. And that's perfectly fine as well. Couple more examples. 3, 6 and -2, 6. So x1, y1, x2, y2. 6 minus 6 over -2 minus 3. That becomes 0 over -5. 0 divided by anything is 0. You can have 0 on top, that's fine. So this is a horizontal line. And it's a horizontal line at y equals 6. You don't really need to know all that. You need to know that it's a horizontal line, though. That's what you need to know. And our last one, x1, y1, x2, y2, -2 minus 3 over 5 minus 5, -5 over 0. Uh-oh, if you try typing that in your calculator, it is going to blow up. You cannot have 0 in the denominator. This is undefined. This is a vertical line. So there are some examples of how to use the slope equation, just very basically, to find a slope. But that's pretty boring. That's super monotonous as well. Like, who wants to do that all day? So rate of change is more interesting. This gives us the slope in an applied situation. It takes the slope and it adds meaning to it. Beyond just 6, -1.4, 0, it tells us something that it means. So we're going to look at an example of finding the rate of change, and this time we have an actual graph that we're looking at. So looking at the graph, the title is percentage of Americans ages 20 to 24 who are married. Okay, so we're looking at people in their early 20s who are married. I see a blue line for women and a red line for men. So we've got two different groups of people. And on the x-axis, we have the year. And then on the y-axis, percentage of married Americans ages 20 to 24. So it looks like we're looking at how the percentage of people in their early 20s has changed as time has gone by. Okay, all things that I've picked up just by looking at this graph. I had no other information. All I've done is looked at the graph. So we want to find the rate of change for each of these line segments. And what that's going to tell us by finding this is how quickly, or what is the average change over time that people are getting married in their early 20s. So I'm going to start by looking at the women, just because their line is on top. Okay, and their line is in blue, so I'll do this in blue. And this graph was nice enough to give us 2 points that we could look at. If it doesn't give you 2 points like this one did, with the 1970, the 65, and the 2010 and the 21, hopefully there'll be 2 easy points that you can pick out, or you can do your best to find 2 that are easy to read. So whenever I'm looking at a graph and I'm determining which ones am I going to make my 1s and my 2s, I always just go from left to right. So x1, y1, x2, y2. There's no real rhyme or reason for it. It's just easier because we read from left to right. So I'm just going to go from left to right. So I'm going to find the slope just like I was doing up above. So 21 minus 65 are my y's, over 2010 minus 1970. So 21 minus 65 is negative 44. And then 2010 minus 1970 is 40. So negative 1.1. But now this isn't just where I'm going to leave this, because this is a rate of change. So there's an application to this. Okay, the rate of change is negative 1.1% per year. This negative 1.1 represents the percent of women that are getting married decreasing for every year that goes by. So this percent here is the unit on the y-axis. Ooh, that's not how you spell axis. And then the year is the unit on the x-axis. So whenever we're doing rate of change, we always want to make sure that we include a unit. And the unit is always going to be the unit for the y-axis per the unit for the x-axis. And I could put this in words. I could say we are seeing a decrease in marriages of 1.1% per year from 1970 to 2010. Right? It's a decrease because the slope, the rate of change was negative, and it was 1.1%. That's what our unit is. And we're looking at this over a span of 40 years. So then we can repeat this for the men. So I'm going to do the same sort of thing. I'm going to label my x1s and my y1 and my x2 and my y2. And I'm going to set up my equation. 11 minus 45 over 2010 minus 1970. So 11 minus 45 is 34, negative 34. And we're looking at the same 40-year time span. And we have the same units here. So for the men, it's a negative 0.85% per year rate of change. So the men's marriages are seeing a decrease of negative 0.85%. Oh, wait, but I have the word decrease, so I don't need the negative, because that would then be like a double negative. So a decrease in marriages of 0.85% per year. From 1970 to 2010. So it's still the slope equation, but now because it's a rate of change, because we had an application around it, we have to make sure that we include units. And in this case, we were looking at the percent that were married for each year that had gone by. So it's the percent per year that has changed in getting married. And that is how you find slope and rate of change.